All right, here's 7.5. 7.5, double angle formulas. Again, kind of a similar theme to sum and difference formulas. We've got a list of really 3 of them. Cosine's kind of funky with its double angle formula, that it has 3 different forms. For any given application of it, you would typically just pick one of them. But the idea here is now, if you have information about an angle, you can make the jump to getting trig values about an angle that's twice the size. Okay, that's why we call them double angles. So first example here, if we have an angle, cosine, we know it's, the angle is called theta. We're looking at its cosine value, but the name of the angle is theta. Angle theta, its cosine value is 5/13, okay? It's in quadrant number 4. So we'll draw a picture of it first, but then what we're going to do is over here, I'll get my work started. We want the angle that is twice the size, okay? Now, I'm going to draw the picture. I'm going to need the picture for the next part because I want to do the same for sine and tangent. I want to be clear, though, that if I chose this form, right, I could go 2, right, cosine squared of u, right, that's just the cosine value of our angle. I could just sub 5/13 squared and then minus 1. So if you're looking at this thinking, hey, can't you get this without the diagram? Yes, okay. You'll see the diagram here is going to be really needed for the next part. All right, so here is angle theta. Best I could tell you about theta, it's in quadrant 4. So it's somewhere between 270 and 360 degrees, probably in the ballpark of 300-ish, somewhere in that range, okay? Need to get y here. Which I can throw right over here. Just doing the Pythagorean theorem to get y. Y squared is 169. We've got to be a little bit tricky here. So we take the square root plus or minus. Could be plus, could be minus. We're down in quadrant 4. Oops, I got to back up. Back up to here. Nope, actually didn't need to back up to there. That was fine, right? But then if y squared is by itself, it means I subtracted 25. This should have been 144. Okay? Then you take the square root, but you do have to remember here that it's negative 12. Okay? We're all set up for the next part that we can get sine and tangent, because if you look at those formulas, we're all set up in that diagram is that I can give you the tangent value of theta and the sine value of theta as well. I'm gonna need those in the next part. Okay. Now, one thing that I know has come up in other areas of Chapter 7 that's been a point of confusion. You got to remember with these formulas, it doesn't matter what you name the angle. Okay. So there's nothing special about the name of u. That's just the notation that was used for the formulas. That's just the name of your angle. Call it x if you want. Call it theta if you want. If it helps you kind of like get information from the formulas. If you need to change this problem to cosine u instead of cosine theta, feel free to do that, okay? If you always want the letter to match the formula that you're referring to, that is something you can do, okay? All right, let's get back over to finding this cosine value. Kind of like the sum and difference formulas from 7.4. We oftentimes just end up with a fair amount of simplifying that we have to do. Okay, there's 5 over 13 squared. I'm eventually going to subtract 1, so I'm already thinking ahead to a common denominator. I'm going to write 1 as 169 over 169. Multiply that first term by 2. Now we're all set up. 50 minus 169. Negative 119 over 169. Okay? Now, important distinction here. The diagram that I have is about angle theta. The cosine value that I just found is for 2 theta. It's the angle that's twice as big. I didn't need the formula to get the cosine value of theta. I didn't even need the diagram. If I'm just talking the original angle, the cosine value was given. This is for the angle twice the size. All right, see if we can't split up our space here. The same thing for sine, and then the same thing for tangent. Okay? Sine of 2 theta is 2 times the sine of theta. I'm going off the formula from above. Times the cosine of theta. Now you can see there, that's really why I needed the diagram, is because for getting sine of 2 theta, I needed the sine value of theta, which was not given to us at the beginning of the problem. We had to go get that. Okay, I'm getting it from right here. Negative 12 over 13 y over r. Once it's all substituted in, we got 2 times, let's see here, negative 12 times 5 would be negative 60. 13 times 13 is 169. Multiply that by 2. There we go. Negative 120 over 169. And we'll wrap it up here. Let's do tangent as well. This is 2 tangent theta, right? This is another one I needed to get off the diagram. Tangent of that original angle is negative 12 over 5. Over 1 minus our tangent value squared. All right, top becomes negative 24 over 5. Bottom will become 1 minus 144 over 25. Let's see, we got to subtract these terms on the bottom. So 1 needs to be rewritten as 25 over 25. Which would be negative 24 over 5. I'm going to give myself a little more room. This is another, we had one of these in the, not one of these, but one like these. In the 7.4 video on sum and differences. One of those tangent ones that just, in terms of simplifying, right? Once we like got everything plugged in, like there's no, up here, there's no variables left. So everything beyond substituting in those values has just been simplifying. you know, but there's just a couple times, in particular with tangent, where it just, to get our exact answer, it just leaves us with a lot of simplifying. All right, basically all that's left is to switch this to multiplication. Five goes in there once, 5 goes into 25 5 times. Oh, we are so close. So close. I got a negative on the top and the bottom, so I'm just going to recognize right now my answer is going to be positive from having two negatives. So 24 times 5 is 120. And then the bottom is just 119. I'm telling you, tangent did it to us again. Just sine, cosine, not, you know, those not especially the sine one, that was nice. Not a ton of simplifying, but it does illustrate pretty well that in terms of simplifying, you've seen it in the last two lessons, it just varies. In some, I don't want to say it's unpredictable, because if you really know the formulas well, you can kind of predict which ones are going to be hard to simplify. I don't think that's an approach you need to worry about. So it might kind of feel random that some simplify really fast and quick, others don't. All right, let's simplify each expression completely. Cosine squared of 25 minus sine squared. Basically what I'm looking for is, of the formulas we had on the previous page, which one does that match? It matches one of the cosine forms for a double angle. So I'd say, all right, this is going to be equal to cosine, but this looks like the right side of the formula. I got to jump over to the left side, which, you know, from here I would recognize that it looks like 25 is u, so this would equal 2 times 25. So that, I believe, would simplify to cosine of 50 degrees, which, in terms of simplifying, I'd leave it at that, right? 50 degrees is not on the unit circle. I don't believe there's any way I can write it as in terms of two angles added or subtracted that are on the unit circle. I mean, all I could do with the cosine of 50 from everything we've covered, I could throw it in the calculator and get a decimal approximation, but I don't think of doing that when the problem says to simplify, right? That's more of an evaluate type of thing. So I'm good on that one. Leave it. Cosine of 50. All right, again, right here, pi over 8 would be my u. So now I'm looking at, okay, which equation does that fit? 2 sine u cosine u. I believe that equals sine of 2u. Whoops. Jeez, just getting ahead of myself. Giving away the answer. At least, not the answer, but the next step. This should be 2 times pi over 8, which, yes, when I simplify that, this would be the sine of pi over 4. Now, this is a different scenario than part A, right, where I get to this point where I'm like, okay, I have the trig function of a single angle. Can I do anything with that? Pi over 4, totally different story from 50 degrees. I go to the unit circle. That is square root of 2 over 2. Now, the other two, like for A and B, there was kind of like a little thought process going into those where you're like, is it a sine? Is it a cosine? Part C, probably pretty obvious that it's a tangent, okay? U is 75, so we could simplify this to say this is tangent of 2u, or tangent of 2, throw in 75 for u. It's the tangent of 150 degrees, okay? Which begs the same question. Can I do anything with that? Can I do anything with the tangent of 150? It again, basically just becomes, for the most part, a question of, is it on the unit circle? There's actually a little more to it, that if we wanted to get real fancy, we could go back to the previous lesson and say, could we use a sum or difference formula to get an exact trig value for that, right? Which we're not going to do that here. That would be really getting pretty detailed, honestly. Really detailed, actually, to take that approach. We wouldn't think of the sum or difference formulas at this point. We just say, if it's not on the unit circle, it'd be like part A. If it is, we'd treat it like part B. It is at 150, y is 1/2. X is negative square root 3/2. Let's see, that'll be a 1 and a negative 1. And you will get negative 1 over square root 3. You may have a copy of a unit circle that this is already filled in, because I don't think you're going to feel like you've never seen this answer before. It's a common tangent value from the unit circle. Negative square root 3 over 3. Okay, each one of those is simplified as far as we can take it. All right, that's all for 7.5, and that actually wraps us up for Chapter 7, Part A.